My name is Massimo Zubelli. I'm the CEO of the group, and welcome today to our speech about the LIFE LAERTHES Project, which is for us a proud area of interest and investments, on which we will pioneering the harvesting or the e-harvesting solutions. And with me, there will be on our speech Mr. Riccardo Marini, who is our chief engineer in Guaresi, particularly dedicated to the harvesting machines. There will be Professor Aurelio Somà from the Polytechnic of Turin and owner and shareholder of Ecothea, which is our partner together with the Politecnico within this project, and engineer Fancesco Mocera, which is who is with us in this project and will lead, let's say, the counter side or the counterpart of Riccardo in these 3 years. Very interesting project for us. Let me introduce a little the group and the perimeter of the discussion of the LIFE LAERTHES. Today, FYELD, it is here in Agritechnica as the first time in its history. We presented the brand and the group in EIMA in November last year. And today we represent and we are integrating and collecting 6 companies: Guaresi Tomato Harvesters, Cult, which is a German branded company of mechanical weeders and weeding removing systems, Ortec, which is a leading company in the world on baby leaf harvesting and transplanters, Agricola Italiana, which is the world leader on the precision planting, particularly for vegetables and horticulture, Toselli, which is again a leader in the niche of spraying pooled sprayers and focused on vegetable and horticulture, and Grimm, which is our company in Jesi, in the center of Italy, which is a leading company in what we call compact self-propelled sprayers. And so we cover all of these companies, the group FYELD, which is the cap and the image of the group on these very famous and historical brands in their segment. Our history began in June 2022, together with some shareholder present here. We entered into the Guaresi company, having on our shoulders, on our back, a financial group, a financial institution, which was High Capital Partners, is an Italian fund, at that time bought 100% of Guaresi. Then at the end of 2022, we added to our financial platform Grimm, the self-propelled boom sprayers. In the middle of 2023, Ortec. And then, let's say, having some with these companies to think about a group or a name of a group in order, let's say, to strengthen to the customer, particularly leverage to the customer mind, the power of a group, which is one of the big jump of these small size companies. We are here in Germany, there are big groups, and we are speaking about small companies focused on market niches, and with FYELD we give to them the opportunity to grow up in several areas of the business. Then at the end of November, in the end of 2024, we added to the group Cult and Toselli, and then in December a big fund which is named Whitebridge, again is an Italian fund made of private investors, decided to enter and to buy the 80% of the group. So today the shareholders are 80% Whitebridge, 16% High Capital Partners, the previous or the original fund who started in 2022, and the small amount to the management, where we represent, of course, with the chairman, the part of people that invested into the group. And then in August 2025, we enter into the company Agricola Italiana, on which we are starting the process of integration into the group. So you see, today the cake represents our business. Big part is the heavy-duty harvesters, tomato and pepper harvesters. We have part of our business on precision planters, sprayers, baby leaf harvesters, parts, and soil preparation, which is for us a very small niche, not interesting in terms of technology for our group. We are today a company of 84 million euro turnover. We have double-digit EBITDA and profit. So we are pushing market niches in order, let's say, we can grow up companies with a good profit. And so we are able to invest in technology like this kind of project. And on the industrial side, not only on parts and other kind of investment we can give to this group on strategic long-term vision, a growing strategy. We sold last year almost 500 units, which is between harvesters and the big machines. Okay, we have many customers. We have 5 production plants you will see later in Italy. We are 250 people, and we sell 70% of our machines out of Italy. So we are no more an Italian group. Our big market is China. We hopefully we develop Germany as a second market. Then we have Spain, Portugal, Turkey. It is another big market for us. So wherever there is a belt or a production of vegetables and horticulture, we are present. This is the area that is usually called high-value crops. And this is why we are investing in this market segment, because we believe there is a space for a big group into this niche of the agricultural machinery business. These are the 5 plants we have in Italy. So we have 2 plants in the northeast in Padova, which is Ortec, Cult, and Agricola Italiana. We have 2 plants in the center, north center of Italy, close to Bologna, Toselli, and close to Ferrara, Pilastri, where there is historically the manufacturing plant of Guaresi. And in the center of Italy is where we have our boom sprayers company. This is the vision of the group. So we started in 22 with this picture. And if you look at this picture, you see that from the soil preparation through the crop care and the seeding and transplanting up to the harvesting. So the vision is to cover for vegetables and horticultural application the full agronomic cycle. So today with Cult and Ortec, we are into the soil preparation area. Green, Toselli, and Cult, we are into a traditional and non-traditional crop care systems. We have seeding, we have precision planters and transplanters, so we cover also this area. Again, we cover the crop care after, and with Guaresi, pepper, tomato, and the baby leaf harvesters, we cover in this area also the harvesting equipment. This is the starting point. We continue to invest, so our aim is, with an open-minded approach to the matter, will be to cover much more this agronomic cycle, including some additional part of the cycle. Then in future, the shareholder gave us the task to add additional other companies. And so there is a strategy in mid-term to have even a bigger company, a bigger group, and so to create the critical mass of investments and profit for engineering and any other kind of investments, which will be for us the next challenge. Just to enter into the Life Laertes, I wanted just to sum up all of these companies. They have experienced or they have a leading component or product when we speak about full electric and electrical things. For example, in Ortec, we have here in EIMA a baby leaf harvester full electric. It is an experience that Ortec has since more than 5 years. So today we restyle. So this is a new machine. So we change a little bit the concept. Consider that today out of our production of harvesters in Ortec, 30% are already full electric. So we already have the competence of some component and driving systems and software control of this kind of technology for this application, of course. Then Toselli some years ago won in EIMA an innovation award for presenting a solution which is not yet in production to make an electrical control of the boom, which will be another competence we have on the table and we will likely develop in the next future, because we see here in Agritechnica many companies components product manufacturer, they are presenting hydraulic and electrical solution. And so for sure, soon we will adopt these systems on our machines. Green, in last exhibition of EIMA, we presented an hybrid concept of the machine. And again, not in production, but we made experience on the technology. This is, again, part of our core competence. In Agricola Italiana, we have a big production of electrical machines. Many of the precision planters today, if you look here in Agritechnica, are driven by electrical motors. This is, again, competence we have on components and controlling systems. We adopted the AI systems which are controlling the robot to remove the weeds from the field. So we have the core competence of AI and electrical controls of these systems. And with Guaresi, last season, we entered, because of the LIFE LAERTHES introduction this year. Last season, we already tested in field a field opener machine, full electric, which made for us part of the season. It is in this moment a test bench for several components, again to add, let's say, add the competence to our engineers, not only to the production and purchasing processes, and be prepared when the company or when the components they will be moved from hydraulic to electric. And this is our competence if we speak about a wide approach to the electrical matters. And then what is LIFE LAERTHES? LIFE LAERTHES is an European program we presented in 2024. Europe, using this name, is promoting a lot the innovation. In these days, it seems that we have to go back another 30 years to carbon, fossil, and all the technologies. But we strongly believe that the path and the engineering development of the next 20 years will be for sure in this direction. And so even if today, speaking about electrics and green technology, some people smiles, but we strongly believe that there will be a big change, and we want to be prepared. Even if we are a small company, being a small company, we think we are in the right direction and we have the right dimension to be flexible and not too much complicated to enter into this pioneering technology. LIFE LAERTHES, we won the project, is almost a 3 million budget program we presented to the European community. So thanks to all of us, because Europe is all of us, we received back 60% of this big budget to support the engineering. So we are investing in our engineering team and with our partners and suppliers. The LIFE LAERTHES is made by mainly four participants. So Guaresi, which is the driving company because of the tomato and pepper harvesters. There is Ecothea, represented by Mr. Somà here, which is an engineering company, particularly engineering or particularly focused on development engineering. Polytechnic of Turin and Conesa. Conesa is number one in Europe production of tomato paste. So we are in this group. We have also some small manufacturer or some small producer of tomatoes, because into these programs there are things for big guys, but also things for small guys. And so we will decline the technology to some southern Mediterranean producer of pepper and cherry tomatoes, which is very important for us because we want to have a scalable technology for big matters, but also for small niche of production. This is all in all the introduction to the group and to the project. Then I leave to Riccardo the speech about, so my colleagues, they will enter much more into the engineering details of the LIFE LAERTHES project. Thank you.
Let's go. Good afternoon, everyone. Let me introduce myself. I am Marini Riccardo, and I'm the head of the technical office of Guaresi, and here am I to talking about the project as a supervisor of this project. As you can see from the title, the project we are presenting is focused on the possibility to actively reduce the pollution due to the massive use of the machine, the harvester machine, the big one in the field. Sorry. Okay. There's technical data of our partnership. Massimo has already spoke about our partner. To achieve this goal, we have identified strategic partners who, through their support and their experience, will be able to lead us to the desired result. Ecothea, our technological partner, which count, among other things, a participation of a previous live ATENA, named ATENA, in collaboration with another Italian company for the electrification of an agricultural tractor, Carraro, if I remember. Polytechnic of Torino, with Fancesco Mocera. The support of university has been essential for the creation of the correct baseline and in the identification of the environmental impact KPIs to be improved. And last but not least, CONESA is our partner, Spanish, is a group located in Badajoz, in Extremadura, that deals with tomato processing, which allow us to carry out the first field test and will contribute to the dissemination on the activities undertaken. And sorry for the photo, black and white. First of all, my intention is to give to you an overview of brand's history, to realize the stage of development we have reached in order to better understand the strategies we have implemented to achieve the objective, which the next speakers will detail by numbers, I hope. The history of Guaresi started almost a century ago, when Hidalgo Guaresi began his artisan activity, influenced by the nervy presence of one of the first sugar beet factories to be constructed in Italy, and designed the small sugar beet farming equipment, like you see in the photo. First design almost 19 years ago. You can see now some evolution of the machine. This is the oldest one. At the beginning of the 80s, the Italian tomato growers need a simple and reliable machine to harvest without using hands. So in 1983, Guaresi designed the first pool-type tomato harvester, the model G84. This machine introduced Guaresi for the first time in the tomato world. The natural evolution of this machine was the G85, and it was the first self-propelled Guaresi tomato harvester. Here you can see the evolution in these 19 years. At the center, this is the standard harvesting machine that we sell in this historical moment. In those years, the interaction between the technician and the farmer was essential to understand which was the points of the machine that need to be improved. At the end of the 80s, this experience allowed the technical department of Guaresi to project the first modern and innovative self-propelled tomato harvester named G89, you see in the photo. It's quite similar to the standard one, but is smaller, quite smaller than the Super G. This was the first machine equipped with electronic sorter, and the first with the vibrating shaker that can ensure for the first time a capacity over 20 tons per hour of productivity. Okay, let's come to the present. You see the two machines nowadays the Guaresi has on the market. Mini G on the left, Super G on the right. The Mini G has two different functions. Allow the farmers to open the field, moving the fruit and the plants in lateral rows to ensure to entry with the big harvester and the tractor. And also you reduce it can reduce the length of every row that needs to be shortened to optimize the transplant of the tomatoes. The Super G, and I speak more in detail after, is the natural sequel of the G89, and is produced in two different sizes, 1.2 meter and 1.5 meter width. Okay, some data for me is important in these 40 years of tomato, give an idea of the innovation of the tomato harvester. In 40 years, we passed from 8 to 80, okay, 80 tons per hour. So in 40 years, the improvement was very, very high. Okay. I'm proud to present you the new Super G, model year 24, working in the field. I was saying the pickup belt, this one is the most strategic system because it's the only in contact with the ground, obviously, except the four wheels. Tomato plants have been cut at the right height, and we have a pair of finger chassis that ensure the load of the material and avoid the loss of tomatoes. At the same time, ensure the maximum drain of soil and dirt to the ground. When the material reaches the high point of the machine, we have to separate the fruit from the plants. This work is made by a shaker that permits the tomatoes to fall down in the undershaker belt and fill with the plants the upper vine takeaway belt. At the end of the undershaker belt, we have a blower fan that is very important to avoid that some branches and leaf can follow the regular flow of the tomatoes, pushing them backward. In some machine, when the farmer needs to reduce the dimension of the plants, the branches and the leaf can be cut by a chopper and put on the ground. Okay, now we have the separate material as good as possible on the left side of the machine. Here we have a location where the people can stand, making some regulation as a speed of the belt and the selection parameters. To ensure the maximum level of security of the operators, we selected a correct thin pitch of the belt to avoid an accident to operator hands. Here we have the more strategical part of the machine, the automatic electrical sorter, single or double, depending on the configuration. We have up to 48 optics channels, then read the product, then flow from PVC belt, and command a pneumatic expulsion system to pull out the non-compliant object, like green tomatoes, soil, stone, or plants. The last part regarding the tomato flow is the unloading belt, what you have seen, just seen on the video, that have to reach a different distance and different height for various kind of storage, such as little bins or biggest truck bed. Okay, here's the cabin, completely new. We changed many things like air conditioning and a new console. More important for me, last but not least, the connectivity is already a standard of the machine. An integrated control units allow to manage remotely the parameters of harvesting, create various kind of maps thanks to GPS. This kind of interaction create an ID card of the field, useful for previous and subsequent activities like irrigation, fertilization, everything else regarding the whole work with other machines. Okay, sorry for this long explanation. For me, it's very important to better understand the starting point and the standard layout that will be the baseline of the new project. Like Massimo said before, the first approach of the Guaresi with the electrification world was the Mini G full electric that you see in this video. This was in summer this year. And the duty cycle of this opener is much lower than Super G harvester. To give you an idea, we are talking about of 2 hours work per day in comparison of 10-12 hours per day of the Super G harvester. For this reason, this prototype, we decided to completely switch the endothermic engine, the power unit, and replace it with an electrical power unit assisted with a battery pack, maintaining all the existing hydraulic line. Start all the videos. For the Super G, the solution is more complicated, or better. There's not only one way to introduce electrical power on the machine. The machine is more powerful than the Mini G. To reach the perfect compromise for the architecture of the new hybrid machine, which is the focus of this project, we needed as much data as possible. So for this reason, the Super G has been equipped with several numbers of speed and pressure sensors, with the aim of evaluating the power required as the boundary condition of the different fields. And at this point, I will leave the next speakers continue. And who will go into the detail, the numbers, like I said before, on how to satisfy our challenge that is to improve machine efficiency and reduce the CO2 emission. Thank you for your attention.
Very good. Ladies and gentlemen, good afternoon. My name is Aurelio Somà. I am professor in Polytechnic Torino, and I founded Ecothea. That was a startup. I founded it 7 years ago in Turin, and Ecothea main activity is to develop in the field of transition, ecological transition, the electrification of vehicles for agriculture and construction machinery. Of course, is the continuation, the industrial continuation of a part of a long-term research activity that I started a lot of years ago. For me, it's very important to be here in Hannover because, and to see here in this room a lot of Italian technicians and managers, because we are proud to be one of the engineer group that we win the Ecothea, the Agritechnica gold medal in 2013 with Merlo, with the electrification of telescopic machine, and that machine was designed by myself with the well-known Amilcare Merlo, that was a big partner of myself in the beginning of this long journey of electrification. Well, I say long journey because now, after more than 15 years, we can say that it's correct that transition is not an ideological electric transition, but we have to focus on the real need of the market. And we can see in this presentation and in this project some example. Now, after 7 years, Ecothea is a system integrator. We develop and we design vehicles, machine, and also some particular components. In our strategy, we buy from the market some components, and we develop some particular component by ourselves. It's very difficult to summarize this activity, but you can see in the slide that from engineering and design point of view, we mechanical design some components, some electric parts, some electronic part, but we can focus on three part of this slide that is our main components. The software and IoT monitoring data. The data will be very important in the future, and of course the transition of machine will boost the amount of data that we need. Then we develop an innovative patented sensorized battery pack. We have our own battery pack that we have an international patent, because in this patent we put the idea of realize a state of charge and state of health directly sensorized on the cells. main technological challenge that we are facing on is to go in the transition electrical, but moreover the energy saving in order to have a real application 5.0 in terms of evaluating the energy saving and energy consumption. Our experience, even if short time, is demonstrated in this slide. You can see in this slide some picture that the vehicles where we work on, we design this kind of vehicles, we participate with this partner that are present in this slide in our first years. We can start with the feed mixer designed for Supertino, an Italian company that was presented here in a previous edition of Agritechnica. Then to arrive to the long cooperation that since 6 years we are developing with Antonio Carraro company for designing both the electric and hybrid tractor. In the case of electric and hybrid, we have numerous innovative patents on powertrain and tractor architecture. In particular, one recent patent of 2022, now extended international, together with Antonio Carraro. We have an innovative architecture that give us the possibility to realize an industrial line that will have at the end both the hybrid and electric tractor on the same architecture. In 2024, as I said before, we also present our own small vehicle that is more or less now a test bench, but will be maybe something more next year. Is a driving rover, a self-driving rover, mixed electric, mainly electric, and also with a range extender with hydrogen propulsion. In order to have a larger autonomy in the field of cropping and also monitoring of the vinegar. And we won the mention and in AIM 2024 as the most innovative project of this. I already mentioned the long activity with Antonio Carraro, and it's important to show this slide to introduce this project today, also to give you an idea about the organization of a LIFE European project and some results that here are presented in the video, and I will briefly describe you. The LIFE ATENA project involved the development of the platform that I briefly introduced you before, of an hybrid and electric tractor specialized for vineyards. The video show the activity and process performed in the field together with the other partner, that is the Aero company, which is the partner of the project, and Aero built several electrified implements. One of the novelty of the project is that in the tractor we have an electric 48 plug that give the possibility to become a first proposal, and we will hope to that it became a standard for the future, to have the possibility to interface the tractor with the several, not one, but several implement. In the project, for example, we have a pre-pruner, defoliator, sprayer, and a controller plow. The tractor is in the class of a specialized tractor with a maximum installed power of 100 kilowatt. The machine is powered by automotive standard electrical system, some of which were developed directly by Ecothea, and there's a 400 volt power bus. The results have been very impressive during the test in field. Particular, of course, in terms of fuel consumption, of course, for the hybrid. For the hybrid, we arrive up to 30% of fuel consumption in comparison with the traditional baseline. And of course, with the electric tractor, with not only we have a significant reduce of CO2 emission, but also a significant reducing of waste oil emission in the field. That is a very important aspect for biological vineyards. I would emphasize that the field test was connected starting from a very important baseline, as we are doing also in this project with Guaresi. In this project, we start, of course, with traditional tractor, and we consider a mixed task cycle typical of different field operation. So, arriving today with the LIFE LAERTHES project, of course, the previous experience are fundamental for Ecothea and also in order to bring in this project engineering experience. And together with Guaresi, we would like to proceed with the electrification of the harvesting machine with particular reference with the Super G that Riccardo previously introduced, and then Francesco will mainly describe in some particular aspect. And in the project, we will work on 2 prototypes of Super G, and will be developed in the next 2 years. Very briefly, you can see here the organization of the European project, of course, a different work package, where you can see different aspects that will be more or less technical, of course, very, very deeply technical, but also an approach to disseminate this long journey of transition and new technology as we are doing today. In fact, it's very important that if at the end of this presentation, we will reach from you some curiosity and some question that we are open to give you some more explanation and answer. The logical and temporal development of the project graphically described in this slide will give you the idea to the interconnection of the partnership. Of course, as you see in my presentation, our experience in engineering of electrification will help Guaresi to go deeply in the electrification. But of course, there is very, very important a strong interconnection with the 2 companies in order to arrive to the manufacturing and realizing of the prototyping and to arrive in the field test. The timeline graphically show the idea of the time that is running in this project of 3 years. It was very important for me to give you some more comments on this slide, because the field testing phase is very, very important. During the period when processing tomatoes, because tomatoes we have in summer, okay? So you can see 3 different moments of the harvesting. We already completed in the summer 2025 the baseline with traditional machine. Now we are developing the first prototype, and the next summer in Spain with the partner Conesa, we will test it. And then with cherry tomatoes, with small tomatoes, we will arrive to demonstrate also in-field testing in 2027 in south of Italy with the derivation of the second hybrid machine and the second prototype. This is my presentation very briefly of our long activities, and now I finish my presentation, passing the possibility to present to my colleague, Fancesco Mocera. Thank you very much.
Good afternoon to everyone. I'm Fancesco Mocera, and I am a professor at Polytechnico di Torino of machine design for electric propulsion system. And what we'll see in the next slide is more or less a very brief summary of what are the main key goal of the project from the engineering point of view, and also from the environmental impact point of view. That is quite an important aspect for the LIFE program. Just to give you a brief idea of what will be the basic structure of and architecture of the machine, of course, we will have the important introduction of electricity on board of the machine. pairing an electric motor to a downsized diesel engine with two main purposes. One is to produce electricity, and in the cases where the mechanical load is too high, this electric machine is also able to help the diesel engine to overcome the applied load. This is possible because we have a buffer, that is the battery pack, the high voltage battery pack that will be installed on the machine. And this buffer will be also will give us the possibility to use another level of voltage on board of the machine that you can see here on this black box of 48 volts, because we want to keep high voltage in the smallest part and area possible of the machine in order to maintain the correct level of safety, and move to 48 volt as much as possible auxiliaries that we have on the machine. This, of course, will give us an important achievement, that is the possibility to reduce the losses due to the oil transportation, and also the possibility to improve the control of the actuators. Of course, this is although the timeline is quite strict, this is a process that needs a little bit of graduality in terms of electrification. So this is the reason why we divided the project into three main steps. The first one, of course, is the monitoring of the baseline to obtain what is the current consumption of the machine in each subsystem of it. Then, based on the requirements that we are processing from the baseline, we are introducing the first step, the Super G Eco, where we will have the introduction of electric energy, substituting some hydraulic subsystem with the electric system. And one important key aspect that I want to emphasize, we will explore the adoption of biolubricants in order to reduce as much as possible the impact of possible oil losses that we can have on the field. Based on the first feedback that we will have in 2026 with the Super G Eco, we will try to optimize as much as possible the architecture and the amount of electrification that we will introduce, because one important goal of the project is to electrify what is necessary to electrify. With the goal of not exceeding the amount of electric system that we will introduce on the machine. And so in 2027, we will have the second prototype that will be the steady state architecture, the Super G Eco Plus, that in principle would have the possibility to achieve the main KPI that we expect. Of course, this is, as I said, is a long journey, although the timeline is quite strict. So what we will do also as a university, we will try to monitor the project together with an external partner that is Tinexta. Monitor every important step of the project, from the engineering to the construction, trying to be as much as possible strict on the timeline. Because as you can understand, the tomatoes will not wait for us to complete the machine. So, as my colleague already said to you, essentially we have also some difficulties from the geographical point of view, because we will need to move these prototypes also in different areas. Because, for example, in the first this year, we monitored the machine in Piedmont and one in Emilia-Romagna. The machine that will be monitored in 2026 will be the Super G Eco Plus in Extremadura, in Spain. And the last one, the Super G Eco Plus, will work in Sicily on 2027. And so, as you can understand, since the machines are quite big, this will involve also some logistic activities. What we expect from this project is, with the gradual introduction and optimization of the electric system, to achieve a fuel saving during the whole season of 24%, with, of course, a related 7 tons of CO2 emission reduction. But as I expressed before, one important result, if properly optimized, will be the adoption also of biolubricant, because these machines have quite a high, a big reservoir of oil. So the lower is the amount of oil that we lose in the field, and the more bio it is, the better. Moreover, one important aspect that is not in this slide is that when we introduce electricity on board, essentially we will also reduce the amount of oil that is required for the machine, because essentially we will eliminate some lines, some hydraulic lines. So this is something that we will explore, the adoption of biolubricant, but in general, the adoption of electricity will allow to reduce the amount of oil on the machine. The architecture that we are developing with all the partners have a key goal in mind, to be as much as scalable as possible, in order to be also replicated on other similar machines that are self-propelled machine with a high level of hydraulic systems. So also in the same field group, we have some example of that. So this will amplify the impact of the prototypes and of the concepts. And of course, one thing that is always not considered enough is that when we introduce electricity, we also, apart from the increase on efficiency, we give the opportunity to improve also from the work side of the machine. So to improve the processing of the tomato harvesting in all the aspects, for the fine control that we can achieve with the electric system. I want to leave you with this last slide, because essentially also, as Professor Somà already mentioned, we are demonstrating, but we can say all the fair is demonstrating that electricity and the electrification can have an impact on the agricultural sector. With LIFE ATENA, we have demonstrated a concrete impact in terms of fuel consumption reduction. So it is possible to improve emissions and consumption in agricultural activities. But as you can see in the last portion of the slide, we have some work still to do, not only as a LIFE LAERTHES project, but in general as people involved in this field. There is still some lack of regulations from a specific aspect that are peculiar of agricultural sector, like, for example, the standardization of DC voltage level and interfaces with the electrical implements that can be attached to the main machine. So this is something that all of us need to work to in order to standardize and make also the electric system more cost effective, we can say. From my side it's all. So I think if you have any question, we are here to answer that. Thank you.